There's something odd going on with the atmosphere around Uranus's poles. I mean, we knew that already, but now it looks like we have an idea why. And it might be messing with how storms form there. We know from Voyager 2 back in the 1980s that Uranus has rings. But what we didn't expect was that these rings would cast such strange shadows on the planet's polar regions. That's because when Voyager flew by Uranus, it noticed that the poles were way hotter than they should have been given how far away they were from the sun. The swing in temperatures between the poles and the equator is about 40 degrees Celsius. It's not like the sun is super far away either. Uranus is only about 4 times farther from the sun than the Earth is. So you'd think that the variation in temperature wouldn't be that drastic? For reference, the largest temperature swing you lines find on Earth between our equator and poles is around 65 degrees Celsius. Now, you might be wondering why the poles are so hot. I mean, if they were closer to the sun, that makes sense. But they aren't. It's quite the opposite. In fact, when Voyager flew by in 1986, Uranus was at its farthest point from the sun in its orbit. Its poles were still hot, which rules out the sun being the cause. Instead, scientists think it's due to Uranus's extremely long seasons. Remember, Uranus is on its side relative to the sun. So each pole experiences 4 years of daylight followed by 4 years of darkness. And the current season started back in 2007. We're about halfway through it right now. So during these long seasons, Uranus's atmosphere has had a lot of time to cool off or heat up depending on which pole you're talking about. As the atmosphere cools, it forms clouds of methane ice crystals which reflect sunlight. And over time, the swings in temperatures between the poles and the equator can get pretty extreme. But for most of us, that's water under the bridge or really ice over the bridge. We don't live on Uranus, so it doesn't affect us directly. But there's a lot we can learn from what's happening there. Like, it turns out that these swings in temperature play a role in how storms form on Uranus. We already knew that the swings in temperature caused by the seasons affected the atmosphere, but we didn't understand the details until recently. A new study published in the journal Geophysical Research Letters suggests that the strong temperature gradients between the poles and the equator help fuel the formation of huge storms and also leave behind weird ripples in the clouds. And you thought traffic was bad here on Earth. Try being a cloud on Uranus and having a bunch of giant storms pop up every few years, blocking your path. Then add in the fact that these storms can last for decades. Yeah, that sounds like a nightmare commute. To figure out how the swings in temperature affected the atmosphere, the author of the paper used a climate model of Uranus to simulate the scenarios. One of them included the effect of the sun. The other one didn't, and then they compared the results. What they found was that neither scenario could explain all of the strange things happening in Uranus's atmosphere. But together they did. Basically, the sun gives the atmosphere a kick in the pants. The initial energy needed to get things going. After that, the atmosphere does the rest. And what it does is form 9 huge storm systems near the poles, 3 at each pole. These storms start as small disturbances in the atmosphere. Then the temperature difference between the poles and the equator provides the energy those disturbances need to grow into massive storms. These storms are so big that they blot out the view of Uranus's surface from Earth, which is how we know they're there. Because we can't see the surface features, we know that something is covering them up. That's why astronomers call these storms dark spots. They're dark because they're blocking the view of the bright underlying cloud tops. These storms rage for years, reaching speeds of more than 900 kilometers per hour. But after about 10 years, they fizzle out. And if you thought that sounded like a long time for a storm to last, check this out. Between 2014 and 2020, one storm stayed active for 6 full Uranian years. That's 25,920 Earth days. I'm exhausted just thinking about it. Once the storms start to fade away, the winds shift direction, sending ripples across the planet. This happens twice a year at the poles and once a year at the equator. The new study suggests that the temperature swings may play a role in forming the ripples, too. As the atmosphere heats up or cools down, it expands or contracts. For instance, when the northern pole moves from 4 years of darkness into 4 years of sunlight, it takes about a year for the heat to reach the equator. And when it gets there, it expands, creating a ripple. Now, we still don't know exactly how this works because our models don't perfectly match up with what we observe. So more work needs to be done, but the new study shows us the way. On Earth, we see ripples in our atmosphere all the time. You might have seen them when you were young and looked at the ocean on a windy day. The wind blows across the surface of the water, creating waves that move across the ocean. Ripples in the atmosphere work the same way, only instead of wind blowing across the water, it's air expanding or contracting as it moves from one place to another. And if you think about the size of Uranus, we're talking about some truly gigantic ripples. They can stretch for thousands of kilometers and change the altitude of the clouds by hundreds of meters. Of course, it's not exactly easy to study ripples that cover thousands of kilometers when you've never seen the surface in the first place. But thanks to the new climate model, scientists can better understand how these ripples form and evolve, which will help them track changes in Uranus's atmosphere over time. And that's important because these storms and ripples are more than just a pretty view. They tell us about what's happening deep inside Uranus. Uranus is an ice giant. That means that even though it looks like a gas giant, it's mostly made of heavier elements and compounds like oxygen, nitrogen, and carbon. We think that Uranus formed when smaller objects in the solar system smashed into each other and stuck together. That's why it's sideways. It hasn't had time to rotate into a more typical shape. But because it's sideways, the atmosphere at the poles gets way colder or hotter than the equator, which creates these crazy storms. And while scientists continue to investigate what's happening on Uranus, we can all take a moment to appreciate that we're on a planet where the biggest storms only last a few weeks. Researchers say that they want to collect more data to validate their model and also look at other factors that may be contributing to the storms and ripples. But for now, this is a big step toward understanding our sideways planet. If you like optimistic science and text stories, stay tuned for more, and thanks for watching.